We are going to look at Chapter 5, Lesson 1 and 2, Sample Space and Simple Events. A sample space is a list of all the possible outcomes determined by a list, a tree diagram, or a table. The outcomes is the number of possibilities when an event occurs. An event can be rolling a dice, it can be flipping a coin, it can be choosing a card, anything similar to this. It could be choosing a shirt or choosing a menu item. Anything that creates an outcome is an event. To determine the total number of outcomes, we typically use tree diagrams or probability tables. You will often see probability tables, also called area models. The tree diagram is most useful if we have more than two events. I know the example here has flipping a coin and rolling a dice, and it still works for two events, but it is more useful if you have more than two events. You can also create a probability table, which is much like a multiplication table. If you notice, they have the outcomes for the dice. They also have the outcomes for the coin. And remember, the outcomes are all the possibilities of that event. You can set it up very much like a multiplication table and find your combinations just as you would using a multiplication table. It is also very much similar to Punnett squares if you've already learned that in your science class. At this time, does anybody have any questions about outcomes, tree diagrams, or probability tables? We also use tree diagrams and probability tables to make a list or a sample space of all the different combinations. If you look at the tree diagram, you can see that one combination is heads, 1, and we make a list over here for heads and 1. You can also see heads and 2. They've made a list for heads, 2. And this list will continue down along with the tree diagram. You will also see the sample space down here in your probability table. You have heads 1 in your sample space, heads 2 in your sample space, heads 3 in your sample space. So you can see how we will use tree diagrams and probability tables to create our sample space. Are there any questions about creating sample space at this time? Let's use some of the vocabulary to complete the table below. In the event of rolling a dice, how many outcomes do we have? Let's take a look at the dice. How many sides are on the dice, and what numbers do we have? You are absolutely correct. There are 6 outcomes when you are asked to roll a dice. To create the sample space, remember it's the list of all the possible outcomes. So what are our possible outcomes with rolling a dice? For this one, you are correct. It is 1, 2, 3, 4, 5, and 6. We will take a look at finding the probability of different events in just a moment. For now, Let's take a look at the second example, spinning this spinner. How many outcomes do you see on this spinner? That is correct. We have 3. Can you give me a list or a sample space of those outcomes? Correct again. The sample space is A, B, and C. Once again, we will take a look at finding the probability of these events in just a moment. How about tossing a coin? How many outcomes do we have with tossing a coin? That's it. There's only 2. And what are those 2 outcomes? You got it. It's heads and tails. See, we only have 2 sides of the coin. Let's flip our paper over and talk about simple events for just a moment. When you are asked to find the probability or a chance that an event will occur on a simple event, it means that there is only one event. There are 2 types of probabilities that we look at. We look at the qualitative probability, which is a verbal description using words. You can see the qualitative probability diagram here shows you that you can go from all the way from impossible, which you have a 0 chance of something occurring, to it's absolutely certain it's going to occur because you have a 100% chance of it occurring. They have various spots in the middle. We can use this to determine if it is unlikely, equally likely, likely, or certain. You also see that equally likely, or 50%, is shown as likely to happen as not. Again, we call this equally likely. It is equally likely to occur. When you look at quantitative probability, quantitative probability is the numerical description. So it is a description using percent. So if you notice, all of our quantitative is down here at the bottom. You have 0%, 20%, 50%, 75%, and 100%. But you know what? We can use numbers all the way in between. There are 2 types of quantitative probability that we look at. We look at the probability that an event will occur, then we also look at the complement event that it will not occur. The complement is huge because you see the not a lot. So when they give it to you, you have to make sure that you're paying attention to. We want the probability that the chance that everything but that item will occur. Do you have any questions about qualitative, quantitative, or the 2 types of quantitative probabilities? Let's take a look at some of the examples below to see if we can determine the probability of some of these events. One of the first things we need to note is how many total outcomes are possible with our spinner. So let's count them. We have 1, 2, 3, 4, 5, 6. And if you notice, both the probability of the favorable and the probability of not favorable are written like fractions. The bottom number is the total number of outcomes. So if it wants the probability of spinning a bee, I take a look at my spinner and I notice there's only one bee. So the probability is going to be 1/6. It is 1/6 because I only see one bee out of 6 total outcomes. It does request that we exchange this for decimal and percent. So let's see if we can find our fractions, decimal, percent benchmark list. Some of you may or may not have your fraction, decimal, percent list. So what we will do along the way is, if you have yours that's already complete, great. If you happen to have misplaced it, we will go ahead and pick up one that is blank and we will fill it in as we go. So let's take a look at 1/6. I know that 1/6 is 0.16, and the 6 is repeating. So I want to get used to rounding this to 0.17, because since it is 5 or more, this number in the hundredths place will go up 1. So we're just going to round this to approximately 17%. So for the probability of 1/6, we are going to say that it is 17 hundredths as a decimal, and that's equivalent to 17%. Let's see if you can try the probability of A by yourself. You are absolutely correct. There is only one A on the spinner, so it also has the probability of 1 out of 6, which is the same as the 17 hundredths and the 17%. Let's take a look at what it means by the probability of an A or an E. Well, this means I can add these two together. So how many A's and how many E's are there? That is correct. There is one of each, so there is 2 of them. So again, that is 2 out of how many total outcomes? That is correct. It is 6. I know I can simplify this to 1/3. We all know what 1/3 is. It is 0.3 repeating, which is also 33%. But just in case you don't have that one on your fraction, decimal, percent sheet, let's go ahead and take a moment and fill that in. Remember, 1/3 is 0.333, which is 0.3 repeating, and we usually say that that is 33%. And remember, if you don't have yours completed, let's go ahead and start filling this one out so you do have another one. Then let's see if you can find the probability of P or C by yourself. That is correct. There is 2 of them, so it is the same as the A or E. You get 2 out of 6, which is equivalent to 1/3, which is equivalent to 0.3 repeating and 33%. How about the probability of M, P, or C? Well, we have M, P, or C. That's 3 out of 6. We know that that's 1/2. That is 5/10, and it is 50%. wonder if it's the same thing for the probability of B, A, or E. Take a minute and see if you think it is as well. Did you find that it was the same? That's great. At this time, do you have any questions about finding the probability of a favorable event? Well, let's take a look at finding the probability of not P or B. And remember, these are called complement events. I'm going to write that down. That is a complement event. So I have to look at the P or B and go, all right, well, there's 2 of those. So if 2 out of 6 are P or B, then how many of them are not P or B? You were absolutely correct. 4 of them are not P or B. So this probability is going to be 4 out of 6. I do need to simplify this by 2, and I get 2/3. I think this one is 0.6 repeating, but there's a couple of rounding things I need to do. So I'm going to take a look at my list. I know that it's 0.6 repeating. And since this, I know that if it keeps going, is 5 or more, I know that it's going to go next door. So we're going to round it to 6,700 and call this 67%. So we know that 2/3 is 0.6 repeating, or 67%. Let's see if you can find out if it's the same for the probability of not M or E. Very good. You did find that they were the same. Because if I take away the M and the E, I know that there are 4 remaining. So this as well is 4/6, which is 2/3, which is 6,700, or 67%. Now that we have learned a little bit about simple events and the probability of simple events, I want to go back over onto the sample space side of our notes and fill in that last column in the table. Let's take a minute to do a few examples on that side. Back over here in the sample space notes, we can also use the outcomes in the sample space to determine the probability of events. So in this one, I want to find the probability of rolling a 1. You are absolutely correct. It is 1/6, or 17%. How about the probability of not 5? How many of those numbers are not 5? You guessed it. It is 5 out of 6. Let's take a look at our list. Our fraction, decimal, percent, 5/6. Well, not quite sure what that one is, so I'm going to go ahead and divide it. And I get, it is 0.83 repeating. And since the next number is a 3, then I know that since it's 4 or less, I'm going to let this one rest. So that's approximately 0.83, or 83%. So we go back to our probability, and I know the probability of not 5 is going to be 83%. Do we have any questions about finding probabilities in the table as well? Can you come up with any examples for the spinner and tossing a coin? I'll give you a minute to do so, and then we will share with the class.